Okay, so we're in section 3.1, and we are going to pick up with example 3. We're going to find the extrema of f of x equals 2x minus 3x to the 2/3 on the interval -1, 3. So extrema can happen at the endpoints, and it could also happen at the critical numbers. So we need to find the critical numbers, and we find critical numbers by taking the derivative. So the derivative of this difference is the derivative of 2x is 2, minus it's 3 times the derivative of x to the 2/3. So that's 2/3 x to the minus 1/3. So that is 2 minus 2x to the -1/3. Now on these problems, critical numbers happen where the derivative equals 0, or where the derivative is undefined. So we need to get this thing written as a solid fraction. So we need to really take the time to move the x to the bottom and get common denominators. So I'm going to do the butterfly method to get the common denominators. So that's 2x to the 1/3 when I multiply that way, minus 2 when I multiply that way, all over x to the 1/3. So critical numbers happen where the derivative is equal to 0. That is when the numerator is equal to 0. So we'll add the 2 over, divide by 2, and let's cube both sides. So one of the critical numbers is 1. Critical numbers also happen where the derivative is undefined, so we set the denominator equal to 0. So it's numerator equal to 0, and denominator equal to 0. Cube both sides. So our critical numbers are 0 and 1. So we are going to, so we're on the interval -1 to 3. We have possible critical numbers of 0 and 1. We're going to make a little chart, and it's going to be left endpoint, critical number, right endpoint. So the left endpoint is A here. We're going to check these in the function. One of the critical numbers is 0. The next one is 1. And the right endpoint is 3. We're going to check these in the function, and just so we see what the function was. So it might be easiest to put this function into your y equals and then just check these values on the table, because we do need exact values. Or you can just deal with the math. You could do f of -1, and that's 2 times -1 minus 3 times -1 to the 2/3. It's -2 minus 3 times. -1 to the 2/3 is power over root. -1 to the second power is +1, and the cube root of +1 is 1. And -2 minus 3 is -5. But it's probably easier to just do this on the calculator and look at your table. And at 0, you're going to get 0. At 1, you get 2 minus 3 is a -1. And at 3, you get 6 minus 3 to the 2/3. 3 squared is 9. Cube root of 9. Let's see. Let's just use our calculator. That's approximately -0.24. Whoops. Then you're looking at these function values. These are the y values. So the highest y value is actually 0. That's our max. And our smallest y value is -5. So that's our min. All right, one last one. Just felt like you needed just a little bit more explanation on how to do some of these that are more difficult. We're going to find the extrema of f of x equals 2 sine x minus the cosine of 2x and we're on the interval 0 to 2 pi. Left endpoint, right endpoint. Okay, so extrema can happen at the endpoints or at critical numbers. So we can take our derivative to find our critical numbers. The derivative of this is 2 cosine x. And the derivative of this, that's a chain rule problem. So it's the derivative of cosine times the derivative of the 2x. So it's 2 cosine x plus 2 sine 2x. Sometimes the book likes to take advantage of opportunities to remind us about trig identities. And a trig identity that we might remember, or we might not, is that the sine of 2x is 2 times the sine of x cosine of x. That's a double angle formula. So we can replace this sine of 2x with what it's equal to. I wouldn't do it on a test unless we have used this identity a lot in this chapter. So it's 2 cosine x plus 4 sine x cosine x. I didn't say, but the reason I knew we needed to look at something was I would have a difficult time trying to get this equal to 0 and to solve it, mainly because of that 2x there. But now I'm able to solve this because I have a GCF of 2 cosine x. So when I take 2 cosine x out of this first term, I'm left with 1. 4 divided by 2 is 2. And when I take the cosine x, I'm left with sine x out. Set these equal to 0. 0 equals 2 cosine x. And 0 equals 1 plus 2 sine x. Divide by 2 here, and you get 0 as cosine x. Subtract 1 and divide by 2, and you get negative half is sine x. And then you go to your unit circle. I'm running out of room, but 0 is cosine x. You find x that has a cosine value of 0, and that's pi over 2 and 3 pi over 2. And for this bottom one, you find x that has a sine value of negative a half. Let's see, sine is positive x. Sine's negative here and here. So you're looking in those quadrants at the y values. That's a pi over 6, so I don't have my unit circle out. That's 7 pi over 6 and 11 pi over 6 if we use our reference angles. So, whoa, we've got 4 possible critical numbers. So we're going to set up our chart. Left endpoint, critical number, critical number, critical number, critical number, right endpoint. Left endpoint is 0. The smallest of those was pi over 2. You can just look around your unit circle at them. The next was 7 pi over 6. The next was 3 pi over 2. The next one you come to would be 11 pi over 6. And your right endpoint was 2 pi. Let me just make that a little nicer. I would definitely let my calculator do this for me. I would plug our equation in to y equals and then I would do second table set. I would make sure I was in radian mode, but then I would do second table set. Let me look at my calculator. Yeah. Table set, which is above window. And get my calculator out. Where it says table start equals, that's where I would put a 0. And then I would go to second table and see what that 0 value was. Then I would do second table set again. I would change table start to the next x value we're looking at, pi over 2. And then I would do second table, check out the pi over 2. So I would let it give me the values that way. And it's -1, it's 3, -3/2, -1, -3/2, and -1. The lowest is, there's 2 of them. 2 are equal. The -3/2, those are your minimum. Those are your extreme minimums. And the 3 would be your extreme max. All right. Good luck. We can go over this stuff on Wednesday.